Hello everyone. Today we will discuss about the electrical energy and power. So we know the definition of electrical potential energy and potential energy difference. We know that if we have to move a charge from one point to the other in electric field, and that work done is stored as potential energy difference. So we are going to recall and use that concept here as well. If you have a resistor R and you have to move a charge Q from this point to this point, and we say that the potential difference between these 2 points is V. I is the current flowing in this part of the circuit. Then we can say that work done in taking this charge from A to B will be stored as potential energy, and that will be potential energy difference. We know the formula, that this formula is charge into potential difference between the 2 points, right? So here we can replace this Q by IT. We know that Q is equal to IT because I is equal to Q upon T. So this gives me this, and this makes it VIT. So here we can define this electrical energy like this. It is the work done to move a charge from one point to the other, right? In other words, we can also say that it is the work done by the source to maintain current in a circuit. Right? So these both are the definitions of electrical energy. Right? So this way our formula for this electrical energy or this work is VIT. If we use Ohm's law where V is equal to IR, we can write it IR into I into T, that means I square R T, and also this can also be written like this, V into I can be written V upon R into T. So this gives me V square upon R into T. So we have three forms of the formula. This is the first form. This is the second form. And this is the third form, right? And the second form also gives this electrical energy is dissipated as heat across this resistor. So this W is equal to I square RT. This gives the heat dissipated across the resistor R. Right? So now we can understand the concept of power, and this law is also called as Joule's law of heating. This is H is heat, and this law is called as Joule's law of heating. Now we can proceed to the concept of power. We know the definition of power. We have studied in 10th standard also. What is power? Rate of doing work. So, here it is rate of doing electrical work. So, if we write the formula for power in this case, this will be work upon time. So, this will give me VI into T upon T. So, this gives me VI. This is one formula. Similarly, we can have another formula also. Power is equal to I square R and power is equal to V square upon R. These are three forms of the power formula. Then we have SI unit of electrical energy. Energy has a standard unit of joules. We all know this. So, SI unit of electrical energy is joules. Right? But for power, we know that SI unit is watt. Right? Now, let's talk about the commercial unit of electric power. You have studied in 10th standard. Kilowatt hour. This is also called as 1 unit of electricity. So, kWh full form can be written as kilowatt hour. So, how do we define it? If 1 kilowatt power is dissipated in 1 hour, then this much of electrical energy which is used in 1 hour is called as kilowatt, 1 kilowatt hour or 1 unit. So, let us find a relation between kilowatt hour and joules. You have studied in 10th standard again. You are studying here relation between kilowatt hour and joules. Now, for this, this can be written as kilo means 1000, watt, and hours can be converted into seconds like this. 1 hour has 60 minutes and 60 minutes has 1 minute has 60 seconds. So, this makes it 3600 and this gives me 36 into 10 to the power 5, or you can say 3.6 into 10 to the power 6 joules. Why so? Because here this is power is joule upon second. Power is joule upon second. So, if we write it, 1 watt is equal to so from here we can write here, this is watt into second, and this can be written 3.6 into 10 to the power 6. 1 watt can be written as joule upon second as we have written here, and this is second. So this second cancels. So this makes it 3.6 into 10 power 6 joules. So 1 unit of electricity is equal to 1 kWh, and this is equal to 3.6 into 10 power 6 joules. So this was all about the basic concept of electrical energy and electrical power. I hope you understood this. That's all for now. Have a nice day.